Hello and welcome to Digital Medboard. Here we go. The formula for calculating the anion gap is sodium minus within bracket chloride plus bicarbonate. The concept of the anion gap is based on the principle that the sum of cations in the plasma equals the sum of anions. Sodium is the major plasma cation. Potassium is present in much smaller amounts, around 3.5 milliequivalent per liter, compared to 135 milliequivalent per liter of sodium. So, potassium is often considered negligible in the calculation. The major plasma anions are chloride and bicarbonate. Thus, sodium plus unmeasured cations equals the chloride plus bicarbonate plus unmeasured anions. Definition: the plasma anion gap is the difference between the unmeasured anions and unmeasured cations, which simplifies to anion gap, sodium minus within bracket chloride plus bicarbonate. The anion gap is especially useful in evaluating the cases of metabolic acidosis. Metabolic acidosis. Metabolic acidosis is characterized by a decrease in pH due to a decrease in bicarbonate. Two main mechanisms can lead to this. Number 1, abnormal acid production, and number 2, loss of bicarbonate. At first, abnormal acid production. Abnormally produced acids, example keto acids, lactic acid, are commonly denoted as HA. These acids react with plasma bicarbonate as follows. For every mole of acid generated, 1 mole of bicarbonate is consumed and 1 mole of unmeasured anions is added to plasma. This leads to decrease in bicarbonate and increased unmeasured anions, resulting in an elevated anion gap. Next, loss of bicarbonate. This can occur through gastrointestinal loss or renal loss. Gastrointestinal loss. The intestinal mucosa secretes bicarbonate via bicarbonate chloride antiporter. When bicarbonate is lost, chloride is retained, leading to hyperchloremic metabolic acidosis. Next, renal loss. Example, proximal renal tubular acidosis. In this condition, the proximal convolutional tubule fails to reabsorb bicarbonate. Bicarbonate is essential as a buffer and should not be lost in urine. Its reabsorption is coupled with sodium. When bicarbonate reabsorption is impaired, sodium reabsorption also decreases. Excess sodium reaches the loop of Henle, increasing sodium and chloride reabsorption via the sodium-potassium to chloride transporter. Thus, serum chloride level increase, again resulting in hyperchloremic metabolic acidosis. Examples of increased anion gap. At first, ketoacidosis. For instance, in diabetes, acetic acid dissociates into acetoacetate and H+, increasing the anion gap. Next, lactic acidosis. Lactic acid forms lactate and H+, increasing the anion gap. Then, increased uricemia, contributing to the anion gap. Chronic kidney disease. Accumulated metabolic acids raise the anion gap. Toxic alcohol ingestion. Ethanol, acetic acid, methanol, formic acid, ethylene glycol, oxalic acid. These acids dissociate, increasing the anion gap. In both gastrointestinal and renal bicarbonate loss, chloride increases to compensate, so the anion gap remains normal, resulting in normal anion gap metabolic acidosis. We got a question. Calculate anion gap. Sodium 145, potassium 4, chloride 90, and bicarbonate 20. Although potassium is given, it is usually excluded from the calculation. Formula for anion gap is sodium minus chloride plus bicarbonate. Sodium 145, chloride plus bicarbonate 90 plus 20, which is 110. So it is 35. Therefore, option A is the correct answer. Points to take away. The value of 35 is significantly elevated. The normal anion gap is 12 plus or minus 2, or typically 10 to 14. Thus, this suggests a case of high anion gap metabolic acidosis, likely due to abnormal acid accumulation. If you found this video helpful, don't forget to like, share, and subscribe to Digital Medboard. Got questions? Drop them in the comments below. See you in the next video. Until then, stay tuned. Cheers.